This video rapidly goes through the June 2010 non-calculator paper, picking up key points along the way. Question 1 is a very simple start. We've got an input and we perform operations on that. So minus 9. Divide by 3, we get to minus 3. If we then add 5, we increase this by 5, we get to plus 2. So the output is positive 2. Then solve the equation. We always know where possible to cope with a number by itself, so if we take 5 from both sides first of all, x over 3 will equal 4. Therefore x will equal, we times up by the 3, 4 lots of 3, x must equal 12. When we have brackets, the trick is to expand the bracket first, generally. So 3y minus 15 equals 18. If we add 15 to both sides, 3y will equal 33. Therefore, y will equal 33 divided by 3, so y will equal 11. And the final question on this first page, work out ABC for these values here. Well, ABC is 10 times 2 times 0. 10 times 2 is 20, but times by 0, we get to 0. Now question 2 just tests a few key skills. Now the first one is sequences. Now we're given a sequence which goes 10, 1,000, 100,000, 10 million. Now the first one is 10 to the power of 1. There's only one 0 there. The next one is 3 zeros, 10 cubed. There's then 5 zeros, so 10 to the power of 5. There are then 7 zeros, that's 10 to the power of 7. These are in terms of powers of 10. And then write down the next term in the sequence. That will just be 10 to the power of 9, due to the pattern of the powers increasing by 2 each time. And then question 3 is the key question, enlargement by a factor of 2, using this as the centre of enlargement. Now the trick here is to think, right, we've got some corners of the shape. How do you get from here to that corner? Across 2 up 1. So if it's a factor 2, rather than across 2 up 1, double it, across 4 up 2. That's the new corner, it's moved to that point there. We then work through all the corners. This one here was across 4 up 1, so go across 8 up 2. That was across 2 up 5, so go across 4 up 10. This was across 3 up 5, so go across 6 up 10. We can now begin to see the shape forming. We'll do a few more coordinates. This was across 4 up 2, so across 8 up 4. This was across 3 up 2, so across 6 up 4. And as you can see, the same shape appears, but enlarged by a factor of 2, with that as the given centre of enlargement. Another key transformation is rotations, really quite simple. If we're asked to rotate this shape a quarter turn clockwise, which of course is that way, but marking on your centre of rotation. Now the centre of rotation is purely a pivot, which I'm going to mark on here for the sake of it, and this shape just turns by a quarter turn, i.e. 90 degrees, that way. So the whole shape will just get turned, doesn't change size, but this shape has turned by 90 degrees and that's been rotated. Now, question 4 tests area, and in this case composite area, i.e. a more complex shape. And I want to work out the area of the cross. Now the trick here, I think, is to turn it into lots of little rectangles or squares and mark on what we know. The length of each long side is double the length of each short side. The short sides are 5, so these here are all 5. The long sides are double, so these are all 10. So this here area will be 5 lots of 10, which is 50. And due to symmetry, this will be 50, this will be 50, this will be 50. But the inner part is 10 by 10, times them together, 100. So the area, 100, 200, 300. 300 centimetres squared. And the perimeter is just the distance around the outside, 10, 20, 30, 40, 50, 60, 70, 80. 80 centimetres around the shape. Part C then just asks why, if we've put 4 shapes together, the entire perimeter will not be 4 lots of 1 perimeter. Well, quite simply, when you combine shapes, there becomes an overlap, and so part of the perimeter is within the shape. So the perimeter is just this part here. So it's not 4 lots of the old perimeter due to the overlap which forms within the shape itself. Now, question 5 is an important question, using the grid to help us. Right, write down the coordinates of the points of intersection of y equals 2 and x equals 1. Well, y equals 2 is a horizontal line passing through y equals 2. X equals -1 is a vertical line passing through the coordinate x equals -1. So this coordinate here has an x coordinate of -1 and a y coordinate of 2. So therefore this is where those two lines intersect. Then we're asked to draw a new line. I think the best thing here is to do a little table of values and just pick a few coordinates, 0, 1 and 2, then y equals x plus 3. So when x is 0, y is 0 plus 3 is 3, x is 1, 1 plus 3 is 4, x is 2, 2 plus 3 is 5. This gives us 3 coordinates to plot. When x is 0, y equals 3. When x is 1, y equals 4. When x is 2, y equals 5. Then draw a line through those coordinates, and this is the line y equals x plus 3. We have now secured our grade C. We're now looking to push up towards the grade B. And this question here explores that by looking at volume. Now, for a prism, and you're given a formula in the front of the exam for this, to find a volume, you first of all work out the area of the face. We're given the face here, so this face is an area of 5 times 6, which is 30 centimetres squared. Then to find the volume, we just times the area of the face by the depth of the shape. 3 times 2 is 6, 2 zeros, 600 centimetres cubed. So we now begin to access the grade B questions quite easily, actually. So, question 7. We're given part of a regular polygon. These angles here are called interior angles. And as a reminder, if you extend a line across, this angle here is called the exterior angle. Now these two angles always add to make 180. So if the interior angle is 168, the exterior must be 12 degrees. Because 12 plus 168 is 180. Now then, the fact you must know for this question, which is how many sides has this polygon got, is that all the exterior angles, which are all 12, add up to 360. Always do. The sum of exterior angles makes 360. So the question is, how many 12s are there in 360? Well, there are 3 12s in 36, so there are 30 12s in 360. There are 30 sides. Question 8 begins to really push us up towards a good solid B and looks at an equation, quite a hard equation, in which we've got a fraction equal to a number. Now there are various ways of solving this, and I think that the best way is to expand the top and bottom first. So we get 21 plus 9x on the top and 20x minus 12 on the bottom. That equals 1. We've got a top and a bottom. And the trick here is to times up by the bottom of the fraction. So this stays as 21 plus 9x, but when you times up by that, we get one lot of this. Well, one lot of 20x minus 12 is just 20x minus 12. We then just have to solve the equation. Now, to avoid any sort of negatives, I'm going to write the side with a large number of x on the left-hand side. So this is just rewriting the equation. I then add 12 to both sides. So 20x equals 33 plus 9x. I then take 9x from both sides. So we get 11x equals 33. Therefore x must equal 33 over 11, which equals 3. So again, when you've got a fraction like this, the trick is to expand first if necessary, and then times up by the denominator. And then rewrite if necessary to make the equation look a bit simpler, and then solve as normal. Part B is just an observation. This equation here is the same as the one above. It's just been flipped or reciprocated. And because the answer is still 1, then the answer to this equation will also still be 3. That's not changed. Now, question 11 is a thinking question. We're given called an addition table, which tells us that x plus y is 5, y plus 2y plus 2x is 19, and so on and so forth. And there are 3 values which make this table work. And the question is, what are they? Now, there's a little trick to this. If we look at the top line, we have 2 x's and a y equal to 5. And on this row here, we have 3 lots of y plus 2 lots of x equal to 19. Now, if we look at the difference between these two equations, the difference is 2 lots of y. So there are 2 more y's, and it's gone up by 14. That's not changed. There are 2 more y's, and it's gone up by 14. So y must equal 7. Now, if y equals 7, this equals 7, then what must x be to get back down to 5? Well, if x is minus 1, 7 take away 1 equals 5. So x is minus 1. The question then is what is z? Well, if x is minus 1, y must equal 7. 7 take 1 is 6. We must add 5 on to get to 11, so z equals 5. And these 3 values will work for the entire table as required. Now question 12 is an interesting grade A question. It's actually very simple. Expanding brackets. Now I think the best thing here is to use the grid method. 5x, 4y, x minus 7y. And then x times 5x is 5x squared, x times 4y, 4xy, 5 times 7 is 35, a negative, so minus 35xy, and minus 7 times 4 is minus 28, y squared. So the answer is 5x squared, 4 take 35 is minus 31xy, take away 28y squared. And there are the 3 marks towards a grade A question. I will mention 13 briefly. This is called the reciprocal graph when it's over x, and it's worth learning this. This is how the reciprocal graph looks. It's got a curve like that towards the axes. Now question 10, again a sort of grade A question, looks quite confusing and mentions these things called sine. Now then, this actually revises and looks at sew, car, tower. And this tells us that sine x, or the angle, is opposite over hypotenuse, cos x equals adjacent over hypotenuse, and tan x equals opposite over adjacent. Now for an angle, this is the adjacent, this is the opposite, and this is the hypotenuse. Here's the angle, opposite, adjacent, hypotenuse. So, what does sine of the angle equal? Sine of the angle equals opposite over hypotenuse. Opposite's 1, hypotenuse is root 5, so the answer is 1 over root 5. And then 10 part B uses a formula at the front of the examination. Given a random triangle, the area is a half times A times B times sine of the angle, where A and B are the 2 sides which form the angle. So, a half, A is 5, B is 4, times sine 26.6. Well, 5 times 4 is 20, a half it is 10. So it equals 10, lots of, and we know from above that this equals 0.447. Work it out, 4.47 as the area. And that's a grade A star style question. Question 14 is then quite a hard one. Definite A star question, this one. We're given 3 shapes and we're asked to find the volume of each of them. Now then, we're told lots of things. So for example, the cylinder has a height of 2y and a radius of 4y. The cone has a radius of 2y and a height of 12y. The sphere has a radius of 3y. Now then, to find the volume of a cone, it's 1/3 times base area times height. This is given in the front of the examination. Now then, base area is a circle, so it's pi times radius squared, and the height is 12y. So 1/3 pi r squared times 12y. This looks very messy, but let's work it through. 1/3 times pi. 2y all squared. 2 squared is 4. Y squared is y squared times by 12y. This equals 4 times 12 is 48. Y squared times y is y cubed. There's the pi all over 3, which works out as 16 y cubed pi. Whoa! And that's just the cone. The cylinder. The volume is the area of the circle times the height. Well, pi times radius squared times by height. 4 squared is 16, y squared times 2y. 16 times 2 is 32, y squared y, y cubed, pi. The sphere, again you're given this in the exam, the volume is 4/3 pi times radius cubed. 3 cubed is 27, y cubed. Now the trick here is to do how many 3's in 27, which is 9, and 9 times 4 is 36. So 36 pi y cubed. So smallest, cone. Volume 16 y cubed pi. Next smallest, cylinder. Volume 32 y cubed pi. Largest, sphere. Volume 36 pi y cubed. And the final question is simplify. Now the trick here is to factorise the top and the bottom separately. 5x squared minus 605. First of all, 5 is a factor. How many 5's in 605? The answer is 121. This is then the difference of two squares, x plus 11, x minus 11. The bottom of the fraction has a factor of 2 and a factor of x, x plus 11. So rewrite this as 5, x plus 11, x minus 11, all over 2x, x plus 11. This cancels out and you're left with 5, x minus 11, all over 2x. And that is how you simplify an algebraic fraction.